Welcome to the lectures on evolution of wireless communication towards 5G. So, in this particular lecture, we will see the scenarios and requirements of 5G. But before we go into that, let us briefly look at some of the things that we have seen in the previous lecture. So, what we see is the generalized system model, which we have briefly described. I would like to revisit that before we proceed. So, what we described there was time frequency diagram, where there was a time axis, frequency axis, and on the z axis there was the channel gain, relative channel gain in decibels. So, the fluctuation as shown over there on your screen is basically the fluctuation of signal strength over time and frequency, and this is exactly what is exploited in the third generation, fourth generation, and rather expected to be exploited further in the fifth generation. So, view of this is sometimes important, and often one needs to recall in order to identify or understand the different mechanisms, especially when we go towards MIMO and other techniques. So, as said that these particular things capture multipath, it captures velocity or Doppler and several things. So, that some of those things we will again see in details at a later part. And again, when you do such simulations, one has to take a cellular or a grid layout. Usually that is the model till now. This particular picture shows around 57 sectors, 19 cells, and each of them should be having such a thing as shown on the top corner. But usually we focus on the central cell, and once we focus on the central cell, the other cell acts as interference, because we have seen that we are moving into the full frequency reuse. That means the situation where we have the entire area using the same center frequency. So, and just a quick iteration of what goes on is usually the reference signal is sent from the base station to the subscriber stations or the mobile stations. Then there is this CQI estimation, that is channel quality estimation at the receiver, followed by which it feeds back the CQI information. Then the base station does link adaptation, that means selects the kind of data rate that it is going to do over a particular link. It also does like scheduling, that means dividing the time amongst the different users, so that the link, the entire area spectral efficiency can be maximized. So, you can inherently see that we are using the terms of definition that we have given before in terms of performance metrics of the system. So, when you do the packet scheduling, there is a breaking down of the incoming bit stream into transport blocks of different sizes, which are essentially sent into this time domain and frequency domain scheduler. So, they essentially utilize these radio resources as per the fluctuation of the channel, as well as taking into account the various delays and traffic requirements of the different users. So, there is a big scale optimization that goes on in the base station, based on which these resource grids, which we will describe further in later lectures, are allocated to users. And this allocation is dependent on the QoS of the users, as said, because there is delay and data rate requirement. And along with it, we have also said that there are several MIMO schemes which goes on. So, again, the base station has to identify the kind of MIMO it has to give to different users, and accordingly a signaling of the different MIMO schemes have to come in. So, there is a whole lot of processing that goes on in order to ensure that the communication link is pretty reliable. And so, I mean, there is additional HARQ, that is the hybrid automatic repeat request. Followed by all of these, there are call admission, and there are several processes which goes on. So, essentially what you see is that to get a reliable link, there has to be several such processes that already runs in the system, and essentially providing some of the new requirements of 5G, where we will see one of which is to reduce the delay, is not a straightforward enhancement of things as it seems to be. So, after discussing all of these, we went on further, and we will continue on this, where we look into the requirements and scenarios. So, we had seen the definitions of some of the terms which are pretty common. We have also talked about the documents which mention about the requirements of 5G and how the evaluation has to be done. So, again, as we have discussed the previous standards, we will also start looking into these with respect to the ITU documents. So, especially as we have mentioned, the IMT-2020 is referred to in the particular document 2083, which describes the requirements and the capabilities, and what it says is that should be far more enhanced capabilities than those described in recommendation M1645. Now, if you look at what is M1645, it is basically the framework and objectives of future development of IMT 2000 and systems beyond. So, this one is going towards IMT advanced. So, it says it is much beyond that, and here we have 2083, which is basically the similar kind of statements as you can see over here. IMT vision, framework and overall objectives of the future development of IMT. That means this is the whole family of things for 2020. That means the IMT advanced and beyond. So, that is why we are looking into these set of documents. These things we have already discussed, that IMT 2020 is essentially 5G. So, we are going to use the term synonymously. We have seen some of the acronyms or the abbreviations, and we have also seen some of the basic statements that have been put forward, like it is expected to be more traffic volume and diverse devices, variety of quality of experience and better affordability. So, let us take a deeper look, because until and unless we understand the details of it, it is difficult to predict or think of or understand the solutions that have been proposed. So, I mean the typical applications which have been pointed out, we have discussed these things like wireless communication applications which are expected to be facilitated by the new technologies are essentially digital economy, which we are almost doing, but probably the scale of which things are going to happen would be far exceeding what we are doing today, and probably one may expect things to go beyond human authentication. So, could be self authenticated things where things could be much faster, and it could go beyond just simple economy. It could be more to physical security things. For example, your smart home potentially, which is probably bigger than your economy in the sense that there is precious life which is kind of guarded. So, you would like things to be done in a way that it is not shunting out the basic requirement in order to maintain security, while it does not allow mal or intuitive actions to be allowed, and that to happen in a seamless manner. So, it looks a very big process, but we have to break down this requirement into smaller requirements and come into specific technical requirements. That is what is the objective of this particular lecture, at least in the initial part. So, of course, there is rapid adoption of smartphones and mobile phones which are driving these things, and the number of devices which are accessing the networks are expected to increase because of Internet of Things. We will see numbers which are kind of predicted to tell you the difference in the numbers when people talk about Internet of Things and when they talk about smartphones. So, that will give us an indication that how this might be one of the major drivers for 5G. And some of the techniques which we have also mentioned last time was like beamforming, MIMO and wide contiguous bandwidth, reduced cell size are our objectives, which we will look at in details in a future slides. So, this basically captures in a broad scale some of the major things which are expected to be there, and again these are not very new to 5G, but there are enhancements which are going to come beyond the 4G. So, we will look at the basis, the primary setup, and we will see what exactly are expected in the 5th generation compared to previous generations. So, we have also read out this particular thing where we said that this particular document aims to establish the vision, the potential user application trends, growth in traffic, technology trends, as well as spectrum implications. It also expected to provide guidelines on the framework and capabilities for 2020 and beyond. So, this is kind of naturally the document should provide us as per the title of the document, and we are supposed to get into the details of it. And the future IMT systems should support emerging new cases. So, these are slowly we are getting into a slightly refined description of the requirements. So, one thing we can see is that very high data rate communications is still there. I mean, at some point we said that high data rate, I mean as you go from 2G to 3G to 4G to 5G, data rate is kind of growing, That's pretty natural because of certain things which we said in the past, that the number of connected devices, IoT and all kinds of things are simply growing. So, I mean the effective bandwidth and also the kind of the traffic, that means let us say today we are more interested in video and other such multimedia traffic, because more is given and people are getting more used to them and there is more demand, more number of users, hence a high data rate requirement is a natural consequence. But we also said that this is not just the only one. There will be a large number of connected devices and we will see certain more descriptions where you will see the massiveness of this. Ultra low latency, again for real time, you can talk about cyber physical system implementations. So, ultra low latency applications are very necessary, for example control applications, and high reliability applications are also essential. I mean if you are talking of medical operations being done through such network connectivity from a remote location, then of course high reliability is absolutely essential, as well as if you are doing certain mechanical large scale experiments or some work, industrial work. For all those things, I mean both these things almost go hand in hand, and they are extreme requirements which are not so easy to bring out. So, I mean the users are expected to be connected instantaneously, this also we have discussed, and the flash behavior, that means they do not want to wait, and I mean this low latency high reliability, as we just said, these are the typical working situations which require such kind of protocol requirements. So, basically the communication system must provide these things, and we would encounter activation of such use cases or protocols under these situations. So, furthermore, what we see is that in the present day communication systems, mostly it is designed with human user in mind. I mean that's I do not need to explain it further, because either it is the entertainment or there is a control. So, most of the time there is an end user who is having a control on the knobs and play button, or let us say I mean fetching a new source of information or doing a search, or maybe making the or pressing the submit button towards payment, or kind of doing a maneuvering of the control through some joystick or even from the smartphone. So, mostly it is the user, and when it is the user is the human being, there is more or less a limit in terms of response time because of the typical latency of human beings. But what is expected is that the next generation thinks there would be a lot of non-human communication, I mean beyond human probably you can say, or subhuman up to you, but I mean the requirements are probably different than what human interface are required to be there. So, there is a design is to consider machine to machine communication with real time constraints. So, this is very important, and if we take a look at driverless cars, so I mean it is pure machines talking to machines and machines controlling machines. So, human interface is almost not there. I mean you can argue with this that no, there would be some human around to take care of emergencies and other things, true, but most of the immediate controls are through I mean machine to machine, and beyond this if we look at drones and UAVs, the pilot would be at a far remote location, whereas this fleet of drones or this fleet of UAVs are supposed to interact with each other, and they are supposed to sense the environment and make a decision and execute the decision on a local level. So, there will be a lot of things that will be going on at the machine level with the intelligence which is not human, which is kind of beyond human intelligence and control. So, there things have to be done in the corresponding perspective. And furthermore, it is also said that it would be like enhanced cloud services are also expected to be facilitated by virtue of this, because probably a lot of cloud services can be accessed and they can be becoming more beneficial or more usable in these conditions. And of course, there is a list of operating scenarios, and I think some of the important ones are traffic control, optimization, I mean real flow of real traffic, let us say cars and all other stuff, and emergency and disaster response. I think this is very critical. E-health is also I think one of the most critical applications, efficient industrial communications are also very important, because if let us say, you cannot afford to have a failure in the systems, because industrial application, big levers moving and a lot of big machineries moving around. So, you cannot happen to give a wrong command, because you might have the system might have chosen the right command, but as it goes through the link, if one of the bits flip, the command becomes a different execution already. So, instead of probably transferring a huge sort of material from one point to another, the whole bucket might be emptied over there immediately. So, it is very important to have very reliable links in that cases, and of course, we have discussed UAV situations. Yeah, high user density is also another very critical thing, which we will see further, like shopping malls, stadiums, open air festivals, and there will be a lot of other users who will be using them in traffic jams probably, or in public transport. So, these are a lot of scenarios which are expected. So, we will see a little bit more graphic descriptions of these where we will appreciate them. And of course, during mobility, we would like to have higher quality while you are located inside a moving platform, let us say a car or a train, and as it's natural that the mobility speeds are kind of increasing, and we will see that the mobility definitions have changed from IMT Advanced to IMT 2020. So, enhanced multimedia services further, so not only mobility, but along with that there are enhancement in the multimedia services, for example, like ultra high definition displays, multi-view high definition displays, mobile 3D projections, augmented reality. So, what we are seeing is that there is a much more enrichment of the media and content that are getting generated and hence being also consumed by the user. So, this particular content, which was not so rich earlier, is now packing much more amount of data into it. Further, the user conditions under which they are accessing such information is also changing from static indoor to high mobile. So, we have lot of challenge to be addressed, and we will see probably a better description of this, and if we understand the details of it, then only we can come up with solutions which are appropriate in meeting such things. So, clearly, if you think of this in a very short note, there is a huge amount of information that is generated, and there is a lot more users moving in a lot more random environment. So, to meet to provide huge amount of information to a large number of highly mobile users is a big challenge which is being seen. Of course, Internet of Things we have already said. So, the number of connected things are going to exceed the human user devices, which we will see in numbers, and further the things that we are talking about can be smartphones, sensors, actuators, cameras and vehicles. So, what it means is that there is a whole variety of different things which get connected. It is not only one type of thing, and hence the energy requirement and energy consumption will be different for the different kind of devices. The transmission power, the latency requirement, because depending upon the applications, for example, if it is a camera, if it will be just one way communication, if there are like sensors and actuators, there will be like two-way communications. In vehicles, of course, it is two-way communications. So, the different kinds of things are going to come up, different latency requirements. Cost and other indices for suitable operations are also going to be different. So, all we are seeing is that one size fits all kind of a solution is not so easy to come up with. So, we are just kind of motivating in this particular part the complexity of the problem, the variety of the problem, and the kind of quote unquote flexible solution that is expected to be delivered in the future generation systems. So, that means what we can see is that we cannot have multitude of solutions, rather we should have solution which easily gels and is flexible, which can transform itself from one form to another, and which can serve the different requirements in a seamless manner. So, of course, there are different application areas for this. And ultra accurate positioning applications. So, precise ground based navigation services are necessary. If you look at present day navigation services, when it was initially available, probably we were very excited that yes, we have a lot of navigation aid these days, but beyond that what things have happened is the complexity of this problem has also increased. Our expectation have also increased. Now, if you go to cities, I mean, there are a lot of flyovers and multi-tier road architectures. There are tunnels, but we expect the service to be available in all situations. Whereas we also require the accuracy. We would almost like our car's location in the lane to be provided as accurately as possible. With today's technology, I mean, there is a huge amount of error given the kind of expectations, because at one point of time we were not having this service. So, when we got the service, we were pretty happy that yes, I know more or less I am in a particular lane, in a particular street, and I use additional information to maneuver to the left or to the right. But now we expect that we to be told in which particular lane we are, and when to take a right turn, when to take a left turn, or if there is a change in the dynamic change in the traffic. So, I mean, there is a huge amount of change that has happened. Further, if we look at drone based delivery of things, automated delivery of things, then of course this is going to be huge. So, with unmanned vehicles, I mean, it's a huge thing. So, in case of relief operations, of course you would like precise information. You would be going around and probably picking up a living thing, maybe a human being who is probably somehow saved himself or herself, and you would like to go to the exact location with the UAVs and probably help the person out of the situation. So, there you need even precise locations. So, what we are seeing is that this new requirement has provided a lot more challenge and an opportunity to provide new solutions as well. Amongst the many drivers which influence the traffic demand are adoption of devices with enhanced capabilities. Of course, I mean, if we go back 10 years and see the kind of devices we had and see the kind of devices we have these days are kind of significantly different. The kind of processing power, the displays, and all are pretty different. So that's one of the driving factors. Use of video, device proliferation, and also we should not forget the evolution of new applications with time. So, we should always anticipate that something new is going to come up, and it is good if if your solution can support certain new changes without much change in the architecture. So, this is another very challenging area, because you do not know what is going to come, but you would expect to be solving it in some manner at least. And this particular document 2370 tells us that it anticipates that IMT traffic will grow 10 to 100 times from 2020 to 2030. So, while the traffic grows, you cannot have a system a priori which is as per the finally predicted traffic, but you would like to invest slowly, and you would like the system to be modular, which can scale, and so that it could finally take the new traffic requirements with added portions of newer portions of the traffic or the system deployment, so that it can grow with the traffic demand, which appears to be very simple, but it is not so straightforward when you go and implement things. So, if we look at the different scenarios or the different drivers for traffic increase beyond 2020 as described in the particular document as we have been referring to, what we see is that there are a whole set of different requirements or different drivers which have been pointed out. So, one of them is the accelerated deployment of new IMT technologies. So, kind of beyond 2017 is expected to be more than 1.4 billion smartphones. We will see some statistics, of course. Then enhanced screen resolution. So, kind of 4K ultra high definition displays are some of the driving factors. Cloud computing. Users are increasingly adopting more services that are required to be ubiquitously accessible. Now, when we say ubiquitously accessible, we will see the definition. It does not mean that you access it over all places on the globe, right? It rather means that over a service area, there is ubiquitous accessibility. But of course, I mean, what it means is that cloud computing should be one of the facilities that to be provided. A growth in audiovisual media streaming, and what is expected that almost 2/3 of the entire mobile traffic would be multimedia, audio and visual. proliferation of ambient screens. So, there will be lot of large screens and surfaces. There are already displays which are like see-through displays, and depending upon situation it can wake up, it can provide displays, and then can act as a window as well. And it's kind of 4K ultra high definition info bearing surfaces. Then shifting demography is also another interesting figure or a fact that which we can look at is the urban migration. So, what it's expected is that around 600 cities produce around 60% of the GDP, global GDP. So, it's kind of pretty skewed. I mean, if you look at the distribution of traffic. So, over entire large area, this is of course over a large area, but if you concentrate on smaller areas, I think similar features happen, that you need to provide a network which can handle huge amount of traffic emanating from a small tiny place, whereas a large area is not having that much demand. So, it is not a uniform distribution of traffic over geographical area. So, this makes the problem even more challenging. So, evolution in the usage or traffic characteristics, so which basically means the emerging services. So, there will be different pattern, there will be traffic asymmetry. So, from the downlink would be from 1/7 to 1/10. So, that means uplink downlink ratio is going to be very different. So, that is what it is saying. So, if we are aware of these things, if the uplink and downlink ratio are different, then we would pre-design the system in a manner which can handle such changes, right. And like subscriber behavior or the the replacement of fixed broadband with mobile broadband. So, basically what we are seeing is that it is kind of expected in many regions of the world that you provide an alternative to the wired broadband through such wireless services. Now, to provide a wireless broadband which is almost equivalent to wired broadband or a fixed broadband service is not an easy problem to handle given all kinds of variations. So, what we see is that there are various factors which drive the traffic increase. So, not only it is just the volume, but also certain changes in behavior, asymmetricity, which are going to change the traffic characteristics beyond 2020. So, it is also predicted that the annual global downloading of applications or apps is kind of 270 billion in 2017. And interesting facts are that the most applications are not used more than once after being downloaded. So, probably if we can ask ourselves, we will probably find that in our mobile phones we have downloaded many applications, or some of them are preloaded. So, that is okay, so that is better off. But if you are not using that application, and if there is a huge number of such things happening, then there is usage of bandwidth. Now, you might question the usage pattern, but it is probably important also to accept the fact that it is a behavioral trait or it is happening, and if you would deny that service, probably it becomes a big question mark whether it is kind of the right approach, or it is kind of helping anyone, because we are not sure about what is going to happen with the app once downloaded. So, additionally the amount of regular updates and upgrades. I mean, if you look at the number of apps that are in your phone, and you would also be aware that there is regular upgradation of the apps, like every week. Months is probably pretty good, but sometimes every day is that it waits for an update, because without update it does not work any further. Now, every device, large number of such apps are happening in this manner. So, although we discount for it, but if we aggregate the total thing, it is a huge number, it is a small number. Sometimes we carry multiple such phones, and although we do not use them, they are still I mean, participating in the overall growth of traffic. So, these are some facts, some factors which, if we are aware, we can probably design to provide service to such requirements in a manner which is going to help manage the entire thing in a nice manner. For a very simple thing is that if it's not a very critical app, we can probably delay the download of information or the upgradation of the app to a time when the traffic demand is low overall. We can distribute it for different users at different times, and many other optimizations can be done, of course with the consent of the user. Yeah, so I mean one more factor that's coming into play is that the technologies will increase the bit rates, that's what is expected, and the quality of experience, of course. So that's one additional factor which is going to come in. Furthermore, the energy aspects are also very important. So what we see is that the energy consumption may become one of the limiting factors, because if there is unsustainable level of cost of operation, then things might take a different turn. So we should be very much careful about the energy consumption also, and this has been one of the important considerations for design of systems. And according to how we lay out, we will see that we will actually try and see one of the particular views in this particular direction and how things can be improved. There are of course many ways, but at least we will see one of the ways. So energy consumption of wireless networks in 2011 was 17 kilowatt hour per year per user. So I mean, if you add up all the users, it was almost 100 terawatt hours per users. So which is a big number, which has already happened in 2011. Now, if you go to 2020 and down to 2030, when traffic is expected to grow 10 to 100 times of the previous generation of systems, then you can easily imagine the amount of energy consumption that's going to happen. So I mean, this is a very important factor. So what it essentially tells us is that most of the designs and solutions should consider the energy that is used overall in the system, so that we can come up with a better design, and our system is already pre-designed to reduce energy, or energy comes as a constraint in the optimization problem which you are usually solving, so that it is already taken into account at the design time and not at a later stage as a post correction. In this particular figure, there is a kind of prediction of the global mobile subscription from 2020 to 2030. So what we see is that it's expected around 10 billion mobile subscriptions in the year 2020, and it was around 6.7 billion in 2013, and it's expected to grow to 17 billion in 2030. So I mean, that's the kind of numbers in terms of mobile subscription that are expected over the next 10 years of the 5th generation of communication system that we are trying to see. And in this particular picture, we are kind of seeing again this particular image is from M2370, which is an ITR document. On the x axis, it's the years from 2020 to 2030, and on the y axis it's the number of different categories of devices. So what we see in one particular column is that it's around 10 point something, nearly around 11. So it's basically the number what we have here, 10.7 billion devices. That is broken down into different types of devices. So there is a feature phone which is kind of 30% roughly speaking, and around 13% of tablets or other smart devices, and smartphones are around a big 63% or 60% plus kind of. So that's the change that has happened over years, where actually earlier this was the major portion of devices, and this was only a smaller portion of devices. And it's expected by 2025 the feature phones would almost vanish in comparison to the entire network. Now, if you have a very tiny fraction of such devices, then what comes into play is that the traffic demand by these devices are significantly different compared to the traffic demand by these devices, right. So Another hidden information which is kind of coming out from this picture is probably the traffic that is generated by feature phones are going to vanish, and it will be generated, it will be dominated mainly by smartphones and tablets from this year onwards, from around 2026, and thereafter you are going to have devices which are much more multimedia capable and capable of and having multiple sensors. So, it will be every user will be generating a huge complicated set of traffic which we need to address. So, we stop this particular lecture here and we will continue on this further in the upcoming lectures. Thank you.